Welcome to the UNCC Finite Element Analysis Project Expo presentation.
The purpose of our project is to create a model with bones and soft tissues that can reliably predict the effects of surgery on the humerus and the scapula. Abacus and hypermesh were used to create FEA models of the shoulder. We wanted to simulate the loads of these surgeries and analyze how the humerus and scapula would respond to these forces. Certain aspects of the model were verified with a scale physical model to emulate bones and soft tissues so that the software predictions could be compared.
We meshed CAD models of bones obtained from the University of Tokyo as a starting point for our finite element analysis models. These models allowed us to obtain realistic human geometries that furthered our work past our simplistic shoulder models. We worked in Slicer to verify the shape and placement of our bones and ligaments by viewing a 3D human body created from MRI and CT scans. Our beginning design iterations are ball and socket joints of increasing complexity. We then added ligaments and spent a large amount of time examining different options for their representation, such as 3D geometries versus beam elements, and how Abacus would interpret these results. Our final model used 3D geometries to represent the ligaments.
Our final design included lossless connections to act as ligaments. Previously we were using beam elements, but these 3D models work better. The lofts simply provide a connection between two faces on different models. We were able to set the model up in Abacus to run jobs. Boundary conditions were applied to the right side of the scapula. The material properties are bone and ligament for their respective parts, and we have a force being applied halfway up the humerus to push it away from the body. The top right image shows the stress variation on the ligaments. The left image is from the same job results, but it shows the deflection occurring, which pushes the humerus to the left like expected. The bottom right image shows the last model we were working on, which has many more lofts than before.
This is a 3D model made using putty and 3D printed parts. This 3D model represents the shoulder joint of the scapula and humerus. Putty was used to represent tendons, and ABS plastic was used to represent the bones. With an applied load, we can see the humerus move while the tendons move with it. Only the tendons and ligaments deform because they are soft tissues.
The project has a model that can run jobs while showing general expected results. The expected motion and deflection can also be seen in the physical model. Next steps, if possible, would include getting a model more accurate, testing it against real-life tests with a human arm, and getting the model verified. This concludes the UNCC-FEA project, and we hope you enjoyed it.